All right. Good morning, everybody. Welcome to the Cambridge Disaster Research Network session on the 2011 East Japan earthquake and tsunami. We're so excited to have you here, and we're so excited to welcome our speakers, Professor Miwako Kitamura and Anawat Suppasri from Tohoku University. Before we begin, we'll do a quick round of introductions for our Cambridge Disaster Research Network co-conveners, starting with my co-host today, Ainsley Chahan. Ainsley, you want to say hello?
Hi, my name is Ainsley. I'm a PhD student here at Cambridge in the Department of Geography, and I study transboundary approaches to hazard management in the Caucasus and Central Asia.
Thanks, Ainsley. Rory, our outgoing convener, would you like to say hello next?
Hi, everyone. Good morning. I am a postdoc in the Geography Department. I'm Rory Walsh, and apparently I can't spell the word minutes. So if you were there 2 minutes earlier, you'd have seen that my spelling isn't that great. Nice to see you all.
To be clear, that's 2 midnights earlier. Maria, would you like to say hi?
Hi, I'm Maria. I'm a PhD student in the engineering faculty at Cambridge, and my research looks at climate hazards, infrastructure, and public health.
Thanks, Maria. And do we have any other co-conveners on the call? I don't think so. Oh, just about to admit one more. Tilly, were you able to join? That's okay. So I'm Ellen Kujawa. I'm also a PhD student here in the Geography Department at Cambridge. And I'm one of the co-conveners for the Cambridge Disaster Research Network. Our objective is to connect hazard and disaster research and researchers across disciplines and to link academic approaches to the needs and approaches of practitioners. So today's session fits really well within that goal. We'll be talking about the 2011 Tohoku earthquake, also called the Great East Japan Earthquake, which occurred on March 11th, 2011. It began with a 9.1 undersea megathrust earthquake about 80 miles off the Senriku coast of Japan. The earthquake itself and the subsequent tsunami resulted in about at least 15,000 fatalities. It displaced hundreds of thousands of people, by some estimates more than 500,000 people, and it led to one of the most ambitious recovery efforts in the world. Today, we'll hear from Professors Anawat Suppasri and Miwako Kitamura, both from the Tohoku University, on their research, which covers aspects of tsunami prediction, recovery, and preparedness. They'll each speak for about 15 minutes, and then we'll do a question and answer period at the end. Miwako, would you like to go ahead and share your slides?
Can you see my screen? Okay.
Yes.
Yes, I'm talking about the analysis of gender imbalance tsunami evacuation behavior, the case study on the Great East Japan earthquake. So, okay. At the beginning, yes, this is the very bold idea that everyone knows about we are studying the disaster, increasing natural disaster and the damage. And also the economic damage has always it's problematic as well. And also the increasing the disaster, also we are trying to getting lots of information and try to make archive data static so many information. However, gender disaggregation data is still lacking. So that's why I think that we are talking about the gender issue. It's very difficult to find the evidence as well. So in my research, and of course, we are trying to change the situation, something like focus on the gender issues. However, it hasn't not been studied exactly yet. We need more research and we need more statistics data as well. And this is like the overview of the Great East Japan earthquake. And of course, we are in the aging society, and many of the aging that area population is women is quite high number. However, in thinking about this kind of background, the number of deaths is during Great Egypt earthquake is so many at women. And also women and men had affected differently by disasters. Women are more likely to die in the immediate after the mass disaster is a case study at the Great Egypt earthquake. And the post-disaster suicide are more common among the men. And there is some number has statistics data coming released from the Japanese government. We can see about men is quite serious situation after the disasters. And this is just talking about the in general, like female background in the Japanese situation. We understanding OECD country, Japan's gender gap is very big problematic. And men accounting the 44% form is Japan's working population. It means if a working is the woman is more equally, Japanese economy is more going to increase, I hope. However, the reality is quite different. And also we understand about the many women leave the workforce after the marriage or the childbirth have a huge opportunity to return to work. This is a middle graph we call M curve. M curve meaning after you graduated school and the woman also they have lots of opportunity to find a job is quite very good company. However, after the marriage and after the great birth, and many women has to be retired. After that, very difficult to find the job. This is a situation. And also in Japan, we have very good situation for the education, for the health. However, lack of the political participation for the women. That is kind of still we are facing the problematic. And this is political participation and the disaster management planning, also the very huge problematic in Japan, because we can see it very clear, even after the Great East Japan quake, it's only few women politicians participate for the politics. It means women's voice has been sometimes ignored and sometimes like it's very difficult to find it. It's women's, the perspectives sometimes a kind of the invisible. And also this is like the case study of female stress following the Great East Japan earthquake. This is actually collecting the data from the Sendai Equality Women's Network. And there's so many questionnaires, mainly structured as follows. They're talking about how the family, about housing, the shelter situation, and how is the woman feeling the situation after the disasters. This is the overall, the result, because so many interviews after that Great Japan earthquake has occurred. However, it's collecting information is very difficult to visible, because so many women's voice is, of course, it's very difficult to like changing to the number. So that's why according to lots of the testimony, I try to make some like visible what they're saying, feeling after the Great East Japan earthquake. And for instance, like question 3, what difficulties did you face if you had a change before after the disasters? And also please describe any difficulties you are currently experiencing the result of the disasters. The focus on the damage for the home and the changes at living places. The houses had been damaged, but their life has been saved. There was strong feeling about having survived. Other dominant words were related to family, such as the parents and the children. Visualization, the free response part of the questionnaire, because many women actually writing about their feeling. However, it's very difficult to see that kind of the number, because that kind of like free response questionnaires is never like appears for the public. And also this is also the case study family stress following the Great Japan earthquake. What kind of words getting together, and like problem with the treatment of pre-existing condition and which caring for your family, because of course the many of the women has to be caring their elderly or sometimes disabled children. Also after the Great Japan earthquake, the situation has been getting more worse and worse. That kind of issue is very difficult to see outside the houses, because every issue is in the house, and even the shelter, some of the children has a mental illness, it's very difficult to see it because the family feeling like it's going to be shame and they try to hide in that kind of children. That is very difficult to find the difficulties for the woman as a mothers as well. This is my background, the case study introduction. We can see that during Great East Japan earthquake, the catastrophe has occurred, so many people died. I choose one place, and you can see it's Otsuchi town. I'm going to explain more about Otsuchi. This is a historical background with the Sanrik coastal area and Otsuchi, Iwate, and the geographic of the Otsuchi town, located in the southern part of the coast of the Iwate prefecture and has a well-developed rice coast. And the core industry, the fishing industry, the coastal fisheries such as salmon, trout, that kind of very rich areas. And the historical background of Sanrik coastal area and Otsuchi town in the Iwate prefecture, this area has been affected by tsunami so many times. I can say that every 70 years there has a big tsunami, and it means they has already prepared such a kind of drill and creating a seaboard. However, so many people died after the disaster. So why people die? Because so many people didn't evacuate. And also we have to understanding about the geographic information. This is the overall, is the areas. This you can see the city center this is like before the disaster, and relocated the residential area is quite flooded. And we can see it's very understanding about just behind the mountain and also the surrounding the sea. It's very difficult to evacuate the situation. This is another area I've divided into 3 areas. This is one of them, the Ando. This area, the tsunami coming from not seaside, tsunami coming from the river. That's why many people, it's very difficult to find the big tsunami because we understand the tsunami is coming from the sea level. However, actually this area damaged by the tsunami from the river. That's why the people never realized that area was very dangerous. This is something field note for the tree study area in the Otsuchi. It's divided in 3 areas. One is called Machikata, the town center, the commercial areas, including governmental office. The next one is Ando, large number of flat residential areas. That's why many people didn't realize the tsunami is coming because residential area, the people just believe that this is a very safe areas. So what I would like to discuss about today is something like the testimony, because many people die in the tsunamis. However, we really have no idea actually the action where the tsunami was come. So that is this is the 100 people's testimony, what their life, talking about their life and the time of the tsunami would come. So this is what I analyze based on this testimony. This is the inside of testimony. This talking about the personally, the daily activities and diseases as a life story, and talking a description of the victim's birthplace and the family situation and address. I'm going to see more detail. So like life stories and the description of the victim's birthplace and what's their life, but just before the disasters. This is the English version. At the high school, she met her future husband, and after graduation, she married for the young age of 20. As thinking about their background before they die, we understanding about background of this area, the situation and social construction, and we can understand the occupation, and also we can understand why she did not evacuate. For instance, for her case, she just tried to pick up her children and also their relatives by car, and then she didn't evacuate, and she has passed away with 3 or 4 children with other relatives together. If she evacuated soon after the earthquake, of course she might be survived. So that's so all the information is in this testimony for the 620 people. So I just analyzed the whole information and what kind of vocabulary is in the 1,620 people's evacuation behavior. Writing, collecting 30 categories and made it what exactly happened. This is so many details. I'm going to skip all that. And this kind of the information, finally I'm analyzed applied PADM models and trying to find what is the key point for the evacuation behavior for those people, why they didn't evacuate. So, and also I'm going to more depth the analyze for any kinds of keyword. So I just divided in 3 parts, and the perception, decision, and action. So what is the time of the disaster, the people didn't evacuate. So the most important for the things was they didn't evacuate because memory of the past tsunami and also the decision prompt others to evacuate did not evacuate. And of course, caring pet believed that the homes was safe. And also I discovered so much detail, especially the woman didn't evacuate because they care elderly people or disabled children. That kind of things are already, of course, as a mother, as a woman, it's very difficult situation if even they don't understand about the danger of the tsunami would come, they can't escape by themselves. So that kind of social structure was quite strong. The emotion, the behavior has connected. So the summary of the analysis of this kind of testimonies. So similarity and differences between this study and international evacuation studies. The keyword is like elderly people, family, community as home ownership, and pets and caregivers. So many things we have to think about evacuation. Why the behavior? Because that is fundamentally important for risk communication, because we have already, especially this area has already experienced the tsunami so many times, and they did a lot of evacuation drill. However, if you think about as a woman, as a mother, as a caregiver, it's very challenging to make a decision at the time of the tsunami. And this kind of the so many analyzing, because I can use 620 people's voices. So this is kind of very rough summary. The testimony was coded using KJ method, and the categories were created. The difference in evacuation behavior by gender, age group, and area were analyzed. They were also applied perception, deception, action for analysis. The characteristics of evacuation behavior, especially by gender, that analysts divided by the described below. Behavior of woman at the time of disaster. Woman was at home when the disaster struck. Did not evacuate immediately, but stayed up the house, picked up family members, or waited for relative to come at home. So if we think about increasing to try to save the people's life, according our research or studies, we have to think about it behind the behavior and also social structure, the culture issues. So thank you very much. I think my presentation is finished. That one. Thank you.
Thank you so much, Miwako. That was so interesting. We'll hear from Anawat Suppasri next. Anawat, would you like to queue up your slides?
Yeah, thank you. I'll share my screen. Can you see now the PowerPoint? Okay, I guess yes. So
yes.
Okay. So let me minimize this. And the pointer. Okay, thank you. Okay, so thank you very much once again for inviting us for this seminar, and we would like to share our knowledge and current progress in our research. Currently I'm visiting UCL for several months, and yeah, so my background is more or less engineering. So Miwako has shown one of her study in one topic, but for me I would like to give more broad area, many topics, very shallow on what is going on in engineering perspective of tsunami, what have been done so far, and what can be the challenge in the next step or in the future. But again, yes, but it will be in the framework of disaster risk, which is the for my talk, the contents of my talk will be cover the hazard, which is how we consider the future sea level rise, and that most of the earthquake is generated by the earthquake, but still 10% or some more or less like that is generated by non-earthquake, or we call non-seismic source. So I would like to speak a little bit about that. And for the vulnerability as well, we have been study. We have lots big data of damage data caused by 2011 tsunami. So I would like to also share what has been understand so far, and what are still our challenge. And yeah, so once we integrate this kind of information, but still we believe that for the stakeholders, still difficult for them for make decision or do the action during the emergency. So I would like to also share my thought on that. First, about the sea level rise. Of course, for you might have heard that the like for typhoon, for flood, for the temperature, but for tsunami as well. This graphic show an example that, for example, the sea level rise. So that means, of course, when tsunami happen, the tsunami will go on top of the right sea level. But from our simulation, we also show that in some case, it depends on the topography, local topography. For example, in this case, even the sea level rise itself is only 70 centimeters, but the final run up the water elevation level can be double of the sea level, for example. And this right figure shows like one area in Japan. The blue area means when there's no sea level rise. And the tsunami inundation, tsunami flood map by normal current sea level. But if we have 40 centimeters, 70 centimeters, how far tsunami can go more inland. So we can do simulation to illustrate or demonstrate how large or how significant impact of the sea level rise. On the other hand, we can use the same thing, but we could convey in a different way. Not for the flat map, but for example, flat map as a right figure, but for the left figure, this is kind of when we talk about the return period and the tsunami depth, for example. You can see here, if we just take a look at the black line, which is the probabilistic tsunami analysis, show us that, for example, in one area, this one they study about in Macau. So if we expected 1 meter of tsunami in one point in Macau, it will be about like every 960 years. But if we have the sea level rise increase for like half a meter or 1 meter, the curve will be shift to the left. So that means even we are thinking about the same 1 meter of of tsunami, but the return period or recurrent will become less. It will be reduced from 900 year to 800 year or 500 year, etc. So this kind of a way that we can explain the impact in more quantitative way. Recently, with my student, we also try to apply, combine with some economic data so that we can, for example, in Sendai, in Tohoku region, we are now expecting like 2 big earthquake and tsunami in up a little bit north of 2011 tsunami or a little bit east of 2011 earthquake and tsunami. And we simulate the tsunami and we combine with our economic data, and we could evaluate the direct and indirect loss, economic loss from these 2 types of earthquake and tsunami. And also, yeah, and yeah, what sector, like agriculture, service, or manufacture, what kind of industry or sector will be impact more or less, or which region, even though the earthquake is generated in the north of Japan, but still from our analysis it shows that the indirect impact supply chains or manufacturing still have shown impact to all over other region in Japan. This is how the way that we are trying to understand more about the influence of tsunami. The second topic will be about the non-seismic earthquake and non-seismic tsunamis, for example. Yes, so for example, this one was in 2018 in Sulawesi Island or Palu City in Indonesia. For example, the submarine landslide, you can see here the water suddenly was generated by the submarine landslide here, like in this animation. So you can see that of course at first the small earthquake happened, but the main cause of tsunami was landslide, which is we are not capable to do the pre-simulate this kind of phenomena, which is quite difficult. And right now we are trying to apply for more a better way to assess this kind of situation. We are now using like slope stability analysis to understand, to estimate like the slidable area or volume or the depth of the slidable locations, and then we can do more accurate simulation. This one is one of our paper that we show that doing this kind of method, we can somehow the red line are what we simulate. We can show that somehow it can explain the situation of the real tsunami height observed in the field. And if you remember last year, in January, there was a big eruption of the volcano in Tonga. It's actually the tsunami was caused by the air pressure coupled with air and water, and it generated tsunami not only in Tonga like this paper, it's local tsunami, but also it also generate global tsunami to Japan and even to the Mediterranean, where there has no water body connect to the Pacific, but the air pressure move forward to all over the world, and it generate the change of the sea level. And in Japan, we also had like you can see in this the right figure, the damage to the fishing vessels and also the fishing facilities. So that's very difficult, especially in case of 2011, the damage was too strong, so everything was gone. But you can see from this photo, some still remain. And in that case, the insurance cannot be paid to the fishermen, so they have to subsidize by themselves. So that this kind of situation, in this way, for small tsunamis, no critical, no large flooding, but it will cause damage to the fishing area, and the fishermen and the related industry, they got suffer a lot. And also we also study the damage to the building, and thanks to the non-seismic tsunami in Indonesia recently in 2018, we understand more like the impact from the not only the ground building to the building, not only from the ground shaking, but also land liquefaction or other types of damage. So I think my time is going to be end, so I would like to skip some part. So for example, this curve shows like the relationship between the tsunami flow depths and the damage of the building. So we can see that, for example, in the blue one is the area where the building sustained the damage from earthquake and earthquake ground shaking and liquefaction. So that's why even very small tsunami flow depth, but already high damage to the building, because the building was suffer from liquefaction before tsunami arrived, for example. And the green one means no liquefaction, but earthquake ground shaking plus tsunami. So that's why it's still very high. But then if we compare with the red one, which is the only purely tsunami, so that's why even this we are thinking about the same tsunami height, but tsunami flow depth, but the damage is getting smaller. So having more data collected, so we can using this kind of data to do more quantitative analysis or assess the risk at the end. We also expand our research to non-housing structures, which is like industry, which is more difficult and more complex about like facility damage or production capacity. Yeah, so I don't think I don't have much time. So if you would like to see more detail, you can check our papers in detail. And yeah, so we produce many kind of relationship between damage and the damage and the flow depths of tsunami for different types of building, different types of mechanical machines or manufacture, different types of industry, and also the recovery process after earthquake for different types of industry. And we show that doing the physical assess damage only, we can see that we might underestimate the real situation because you know, like if we think about the industry like this, even 1 meter of tsunami can destroy the electricity panels or the machine things in the factory, but even though the structure can still survive. So this kind of that. Last but not least, when we talk about local stakeholders, it's quite difficult to convey this kind of information. Like, let's say 1 meter of tsunami every 100 years, or the chance of 5%, something like that, is quite difficult to communicate with the stakeholder. So we are trying to convey different way of illustration of our result by showing, for example, if we think about Sendai Port, if we show in a map, like if the earthquake magnitude 7 happen in this red area, the tsunami will be definitely higher than 1 meter, for example. So then by giving this kind of information, the stakeholder can have more idea, like, okay, which area they should have paid attention, or they don't have to do non-necessary stop their production or business, for example. Yeah, so in Sendai, we have many stakeholders here. So we are discussing with them about this. And yes, I think I would like, and my 2 more slides will be about, like, so right now, not only the decision making, but also related to the tsunami warning level, and also the physical coastal defense things along the coast of Sendai. For example, we have 7 meters of the seawall, but for the government perspective, if we expect that tsunami more than 1 meter, they have to give advisory. They have to release advisory, but it's still difficult for local stakeholder if they should evacuate, even though they have a big seawall in front of them. So there's no right or wrong decision, but I think this kind of discussion should be made for each industry, so that they can plan for better reaction after the warning. So my conclusion will be, again, so we need to study more how the influence of sea level rise will influence on our current defense, and how much it could be enlarged by this sea level rise. And for non-seismic tsunami, we still have less understanding about this type of tsunami, and we need, in Japan, we have many observational networks, so that can be helped for the warning. But for other countries, we still very difficult to respond to this kind of tsunami. For damage assessment, we have more data, but still we need to understand more about the hazard here. And the warning things that I already explained. But last but not least, not included in this presentation, but as mentioned by Miwako, we still need to understand more about disaster vulnerable person, which is non-engineering perspective, but we'd like to integrate our engineering result with these topics. And also, finally, we also working with disaster medicine or doctor. We have the casualty data of 2011. We are trying to understand what the cause of the death and things, the condition of 2011. So we would like to understand more in medical perspective. So hopefully we could propose more countermeasure against future tsunami. Thank you so much for your listening, and happy to take any question.
Fantastic. Thank you both so much. I think those were really interesting presentations and great to hear a little bit more about your research. So now we're going to open the floor up to questions. If you could go ahead and raise your hand via the Zoom function or pop your question in the chat, and I'm happy to read that off. And